An apology. I had actually wanted to show you guys a lot of cool examples of probabilistic inference today, but some of those algorithms aren't yet for prime time, so I'm going to show you something else today. But what I want to show you and what I think would be more useful is to really show you the platform that we're working on at Microsoft for doing scalable data analysis with R and Spark. That's the goal for today. So let's unpack that a little bit. The hope for it to be scalable is that it could accommodate large data sets. That could mean a lot of different things. One thing it could mean is that you have far more variables or features than you have actual data, right? So something like a recognition example. You could have data coming in streams, or generally large data where you actually want to do some inference. You don't want to just predict, you want to do inference. I'm not going to show you or explain why you want to use Spark. I think everyone here wants to use Spark, so that's cool. But R has tended to be not the primary API for people that use Spark, right? So I want to show you guys why I think R is awesome. I've been using R for a long time, and I think you guys shouldn't be afraid to use R if you're planning to do statistical analysis. R is great at statistical modeling, visualization, and inference, but it's also a functional language, so it puts itself pretty well aligned with Spark and with Scala. It's also very lazy, just like I am, so it makes it easy to develop functional pipelines for doing modeling and data analysis. My goal, and I think the goal at Microsoft, is to let you take your R code, your existing R code, all your code base, and port directly to Spark. Not have to rewrite it, not have to re-engineer it in different languages, different APIs. That's the goal for us. So here's my background. I studied stats and machine learning at the University of Toronto. That's kind of why I fell in love with R. I was warned by my professors that I should learn SAS or Stata because when I get to the real world and people want to hire me, they won't hire me if I know R. I didn't listen to them. I still learned R, and that's what I focused on. I joined Microsoft about a year ago through an acquisition of Revolution Analytics. Has anyone here heard of Revolution Analytics? Not bad. All right, quite a few of you guys. Awesome. So we got acquired about a year and a half ago, and we had an enterprise solution for doing R in Hadoop and in databases, and Microsoft wanted to put it in everything that Microsoft has, including their cloud platforms. So I'm using R for about 7 years now, Hadoop only for about 2.5 years in work, and Spark just for a year and a half, right? So that's kind of why whenever I have a data analysis problem or I want to do machine learning, I think of R first, all right? Just a show of hands, how many people here use R frequently? All right, and keep your hand up if you use R as your primary language for data analysis. All right, quite a few guys, awesome. Awesome, all right. So for those of you guys that use R a lot, you probably know it's very expressive. It's very easy to write a couple lines of R code that will train a model, will make really cool plots, interactive plots even. So it's really, really fun for that. It's open source. It's been open source for a very long time, since its inception. So there's been a lot of contributions from all over the world. It's very, very extensive and extendable. So there's over 10,000 packages on CRAN. The separate suite of packages specifically aimed at biodata analysis called Bioconductor. So there are 10,000 packages there, and probably another 20,000 packages on GitHub. So a lot of packages in R. Its focus is on stats and machine learning. About maybe the majority of those packages are all for statistical algorithms, machine learning algorithms. It has some really cool data structures. I think data frames that Pandas borrowed and eventually became the API in Spark were actually kind of influenced or inspired by what data frames were in R. There's a huge user community behind R. At first, it was mostly in academia, so that's how I fell in love with R, and that's why I was kind of warned that in industry people don't use R. But fortunately, that's changing a lot. Not just Microsoft, but and Oracle, and a lot of big companies are putting a lot of energy and a lot of emphasis behind R, so it's definitely growing. It was designed by statisticians, so some of the most core principles in statistics, whether it's modeling, whether it's visualization, were embedded in R from the very beginning, right? So the formula syntax that everyone had used in R was there from the first iteration of R, whereas something like Python didn't get it until stats models came out much later, right? All right, where does R fall short? It was designed by statisticians, right? That's kind of a crude joke, but it is true. The design principles behind R weren't so much about performance or concurrency, those kind of things, but more about how to do interactive data analysis quickly and easily, right? They didn't put a lot of time into thinking about how to make it scalable, It's very inefficient at element-by-element computations. So those of you guys come from Python or the languages that you want to write for loops, you'll quickly get yelled at and say, don't do that in R. So it's very inefficient at those type of operations. Everything that exists in R is an object, and that object resides in memory. So it will make large demands on your system resources, especially your system's memory. Your data sets must fit into your system's memory as well. There are some packages that try to alleviate that, but for the most part, all your data sets will be in your system's memory. All the functions and algorithms are single-threaded, so if you have a multi-core machine or hyper-threaded machine, too bad. R is not designed to take advantage of multiple cores. All right, so Microsoft R Server, that's what Microsoft bought my last company for, Revolution Analytics. We designed an enterprise version of R. I'll show you what that means in a second. But basically what we want to do is we wanted to break through R's memory shackles by using data sets that weren't in memory. So we call them XDFs, for external data frames. So they could reside on disk. This could be local disk. It could be HDFS. It could be SQL Server. And we have bridges to work with distributed environments like Spark, Hadoop MR, and Teradata. Right, so I'll show you the Spark stuff today. One of the core principles behind Microsoft R Server is this VODA concept, which means write once, deploy anywhere. So the idea behind that is when you write your code to work locally, you don't want to have to go back and rewrite that into a jar or into a Scala application. Right? You want to be able to just change maybe one or two environment variables and have that run automatically in your Spark cluster. So that's what VODA is for us. That encourages API reuse or just code reuse in general. So we don't want you to have to keep re-engineering your code base for different environments. All right. And deployment should be possible within seconds. So you can develop your code locally, but once you're ready to deploy it in a Spark cluster, it should be very easy to do so. And beyond that, you spend a lot of time in our cloud services to make your models and your applications available as web services online as well. All right, so here's kind of a overview of the Microsoft R Server architecture. So the blue box on the left, that's the open source R, the vanilla R that's single-threaded and all in memory. We have another community offering called Microsoft R Open, which is basically just CRAN R, but we've bundled it with the Intel MKL libraries, which are multi-threaded. So for all the linear algebra stuff you do in R, they'll be automatically multi-threaded. But the more important pieces of MRS, or Microsoft R Server, are those green boxes, which really the only one that I care about is the SparkR box here. These are our high-performance algorithms that are written in C++ and can be converted to Scala applications or Hadoop jobs as well. The other two things here, ConnectR and DistributeR, are basically bridges to work with other environments. So ConnectR like to connect to file systems like HDFS or Teradata, and DistributeR will allow you to convert your ScaleR algorithms into Spark jobs. We support a lot of cloud-based installations. So as you can imagine, Microsoft has our focus in Azure. So we have Windows VMs, which even though it's Microsoft, I don't recommend using Windows VMs anymore. We really put all our might and develop it into Linux VMs and HD Insight clusters. So I'll talk about that a little bit later today. We support all three major vendors of Hadoop, including Hortonworks, Cloudera, and MapR. We also can be embedded inside of databases like SQL Server and Teradata. All right. There are actually quite a few APIs for R. So before I get that, here's what I think of R. It's very, very lazy. So unless R gets in front of an actual computation, it won't do anything, right? So just kind of lay around and wait for you to push it around. It is a functional programming language, so you can make some really cool functional pipelines and extend them easily, but it will crash if you don't take advantage of other things like that. Okay, so the three APIs here that I want to talk about. I'll mention SparkR probably at the end because it's the one that I've been using the least, although it is probably the most important one, but I'll tell you why it's the one I use the least right now. The one that is bundled with Microsoft R Server is called RxSpark. So what that allows you to do is allow you to convert your local R code into Spark applications. And it's all done behind the scenes without any Spark writing by you. And the only abstractions you have to learn are those of the RevoScalar package. So the data resides on distributed file systems as XDFDs. So I mentioned XDFs were the external data frames that we use to break the memory barrier of R. XDFDs are basically XDFs on HDFS. Okay? And then all the functions, the algorithms and transformers that we have are basically traditional R objects, traditional R functions. And when you invoke a Rebel-scalar algorithm inside a Spark context, it will create a Spark application, convert those XDFDs into RDD data frames. Okay? For jobs that have multiple iterations, it will cache those results per iteration, so you have to keep restarting the Spark application. And there's no need for you to write any Spark code at all. Currently, this is available through the Azure HD Insight platform. If you want to use a different platform, it's available as well, but you have to dig a little bit further, so pull me aside and I'll tell you how to find it. We're currently using Spark 1.6.2. We will hopefully support Spark 2 in, I don't want to give you a timeline, but hopefully by end this year. The one really cool thing about RxSpark is that it also provides a really convenient way of doing sort of functionals or user-defined functions inside of a Spark cluster. So you take your existing R code and have it run on each partition of the data set, so each D of the XDFD, and summarize results that way. So you can define your own parallel shell memory algorithms as well. All right, the most common API for R and Spark is called SparkR. It's been shipping with Spark since 1.4. Machine learning functionality was starting to be exposed after 1.5. It basically provides a wrapper for Spark data frames. More specifically, allows you to invoke functions directly on the JVM using an RPC server. Okay. It's inspired by dplyr package. How many folks here have used dplyr? Quite a few, right? All right, so it is inspired by dplyr, but it doesn't take advantage of the coolest thing of dplyr, which is non-standard evaluation. Right? So what I mean by that is in dplyr, you take a data set, a data frame, and so this data frame is called taxi, and you would say group by, which is same as group by in Spark and Scala, and you say what column you want to group it by. Right? And here, when you do group by, you don't specify taxi again, you don't do a $sign or any sort of indexing. It automatically understands that you're in the environment or in the scope of that data frame, so it will find the column from that automatically. And then you summarize it or aggregate it and get some average results based on that grouping summarization. This weird operator here, do you guys know what this is? This is the pipe operator, which is it's really cool. It's inspired by the the bash pipe or the F# forward operator. But it basically tells the interpreter to compile the statement as a nested function call. So take these results and pipe it into the first argument of the next function, right? So it allows you to really create nested function calls in a very simple, intuitive way. So that's dplyr. SparkR is a little different, right? Same functions, so actually a lot of masking of dplyr functions, but it still requires you to specify the column names in standard evaluation, right? So you have to say taxi, $, pickup, and hood. Which is kind of annoying because if you had a code base written in dplyr and you just want to change the data frame, the data source, to a Spark data frame, it wouldn't work. Right? You get all kind of weird results. There's been quite a few attempts to alleviate that, but that's how it is currently in SparkR. It also has limited machine learning functionality right now. So the currently supported algorithms are GLMs, naive Bayes, and k-means. I think there might be more coming soon, but up until 1.6, actually it's only GLMs and k-means, and for GLMs it's only the binomial link function as well. So it's still quite far behind PySpark and obviously behind Scala when it came to machine learning functionality. The one kind of exciting thing about Spark 2.0 is the introduction of two new functionals called dapply and gapply, which allow you to provide a new functional to do user-defined functions. So that's really exciting. That's one thing that isn't available in the other API I'll talk about right now, but it's very similar to what we have in MRS with the RxExec function, which I'll show you an example of later today. Okay. I don't have the time, so I'm kind of guessing the time. Okay. All right, so here's one kind of annoying thing about SparkR is that when you load dplyr and then load SparkR, you get this really ominous looking warning saying that there's a lot of masking of function names by the two packages, right? Just kind of another example where you have a hard time reusing the two libraries together. And if you want to reuse your code base, you have to rewrite it a little bit. So that's kind of annoying. All right, so the last one I'll talk about is SparkR. How many folks here have heard of SparkR? A couple of you guys. All right, so SparkR is much more recent. It's being developed by the good folks at RStudio. And basically what it's doing is it's trying to make it a lot simpler to use dplyr and use the sort of tidy universe of what RStudio is working on. So one thing about dplyr, the package, is that it already has a SQL backend. So you can already use dplyr to connect to SQL databases, SQL tables. So since all of Spark data frame operations are conducted at the Spark SQL level, we can directly use dplyr SQL backend instead of creating a new one. So this is really cool. In this case, we can directly use the same line of code from before. So in SparkR or dplyr, this line of code would work. You know, specify column, the $ or the actual column name explicitly. You can do it using non-static evaluation, and it will work. It has full support for all the Spark ML. The pipeline's a little bit missing right now, but all the algorithms, including perceptrons, LDA, so on and so forth. There's no UDF support yet. There is a development branch that has UDF support. I think they're still trying to figure out how to sort of merge it in with what SparkR is doing. So it's still not explicitly or publicly released, but it is kind of there in the background. All right, so SparkR is meant to be a domain-specific language. So it's supposed to let you reuse your same dplyr code with SparkR data frames or Spark data frames. The core RPC layer is not actually inside SparkR. It's inside another package called Spark API. So if you want to write your own extensions for R that connect to Spark libraries, you can use Spark API. So there's also one now for H2O sparkling water, which I think is a talk about tomorrow or later today, but not to the R API, but there's one now available through the Spark API R package. All right, and lastly, since I talk about Microsoft stuff, the best way to really utilize Spark in the Microsoft ecosystem is through Azure HD Insight. With Azure HD Insight, you have to choose an API. You can use all three. That's what I normally do. And you can use any combination of them for your data science pipelines and functions. Stop worrying about optimizing your code or rewriting your function. Just focus on developing cool things. All right, so let me show you a couple of quick examples. So the cool thing about SparkR, which I am really happy about because I'm not a Scala expert by any sense of the word, is that you can start writing really cool stuff in SparkR without knowing much Scala or Spark at all. All the dplyr statements are converted to SQL statements and sent to Catalyst and optimized, so that's kind of nice. Is that visible in the back? Not really. Yeah. Is that better? All right, so the font's probably not the right choice. But anyway, so here's an example of how to import a data set from CSV into Spark data frames. This WASP syntax is similar to, I guess, the S3 syntax in Amazon. Basically a pointer to an Azure storage blob or storage container in HD Insight. You can create a Spark application, a Spark context using a Yarn client application. And then you can use SparkR Read CSV function, right? So it's very simple. It's very intuitive. What's nice about it is that it's very much like R, right? There's nothing here that's not R-like here. So in the SparkR API, for instance, the header argument is actually a character. It's not a Boolean value, which always threw me off. I always got that wrong, and it just seemed a little different. This is all just like R. The important thing to note is once you read the data set in, so this data set is a data set from Freddie Mac. It contains the single family originations of mortgage loans up until 1999, I think. So when you get the data set into Spark, it will have a couple of different class attributes to it. The one that you can see right away is Tibble Spark and Tibble SQL. Right? Tibble is just a cute name of saying table, I guess. So table SQL is basically how Spark will convert, or SparkR will convert dplyr functions into SQL methods, which will get sent to Spark SQL. All right? And you can see here, we can see the Spark data frame on the Yarn client. All right. I got to zoom out a little bit. Then again, if you guys have seen dplyr, it's exactly like dplyr, nothing different at all. So this code could have been written first for dplyr, and then you could change the data source to a Spark data frame, and it would work. That's actually how I do a lot of my examples from my trainings. So this is a rename method. Just going to rename the column something more useful. The data did not have a header, so I had to do that manually. All right, and then if I wanted to do something like, for instance, get the date of that loan, date of origination, it's actually kind of hidden in behind the loan number field. So the loan number field has a F preceding it, then the year, and the quarter. So that's how the loan is specified for its date of origination. So I can use dplyr functions to just mutate that, take out the characters that belong to the year, and then convert that into an actual year. Had to be a little bit tricky here in that 2000, anything in 2000 actually only has one character for whatever year it was in 2000, whereas anything before that has two characters rather. So you just have to sort of pad it in correctly. That's all it is. That's really nice. If I actually run this, you'll see that these are all transformations, so they happen instantaneously. Then when I do an action, it actually does happen pretty quickly. It's not much overhead in creating a Spark application or anything like that. All right, it's kind of running behind time now, but here's an example of doing aggregation. So I'm just going to aggregate by year and by state, and I'll get the year and state average credit score. I could put that into a function instead. So the one kind of annoying thing about dplyr is because it uses non-standard evaluation, it's a little bit hard to program with. So in this case, I wanted to program with it, make a function where I would specify which variable to get the average values for. I have to be a little bit more specific there, so I have to say summarize, and then say interpret that variable as an actual object, right? But now it's a function, so I can just call it directly in a function call. I want call that function not for credit score, but for DTI, debt to income, and get the yearly debt to income per state. And then I'll get a plot for that. So this is just a wrapper to a D3 package for doing plots. So you can see here how DTI changes over time. Fortunately, Safari does not like this plot at all. Okay, it's kind of static here. I'll share this with you guys so you can see it on your own. What's kind of cool is you'll see up until 2005, DTI keeps going up and up and up. So I don't know, it's kind of cool. All right, running out of time. So you could do a lot of machine learning with SparkR itself, but I wanted to talk about all the algorithms we have at Microsoft. So this is what we have currently available. We are releasing a whole bunch of additional algorithms in November, including some probabilistic learners as well, a lot of really cool NLP learners as well. Right now, here's our suite of algorithms. Quite a bit of overlap with SparkML. Here's how it works. So I'm going to first devise a little function that will take the data set that we have. I didn't show you where I sort of split it into training and test sets, but that's what I did. And then I'm going to take the data set and create a sort of formula syntax for it based on the default flag variable as the response variable, and everything else is the feature variable. And then I'll say which algorithm I want to use. In this case, I want to use a logit. All right. So because it's a function, I can now sort of make this into a functional and call many functions at a time. So what I mean by that is I'll create a Spark context. So this is how we create the Spark context inside of MRS. It's not really a Spark context. It's basically an environment variable that says any Rx function that gets run will now be run in a Spark context. So it will create the Spark application for you on when it receives a new Rx function. So now I'll create a list of models I want to create. So a logit, a decision tree, a random forest, and a gradient boosted trees. Fortunately, random forest is a trademark name, so we call it decision forest, but it's still the same algorithm underneath. And then we use the RxExec functional, which is like the dapply or the lapply functional, and say estimate that model over the data set each time. Right? So now this is the one inside my cluster. I'll get to do these in parallel across my cluster at one time. Here's how I score it. So it's a very simple operation again. It's very similar to the predict function in BaseR. Predict that model based on data set and output it someplace else. There's one typo here. Actually, this should be model, not the actual variable name. It should be the argument. But I guess in this case, it's the same scope, so it works. Here's the results. So I scored all 4 models. In this case, the GBM, the gradient boosted trees, did the best. The logic did pretty well as well. The random forest did very poorly, so probably need to spend more time validating that one. All right, that's that. So next steps are, right now I show you 3 different APIs. I only really show you 2 APIs, but I talked about 3 APIs. The one kind of annoying thing about the 3 APIs is they're all different. So currently each API uses their own backend to create Spark sessions and Spark contexts. So you can't share objects between these APIs, right? If you create a Spark data frame one API, you can't just pass it on to another API. We're planning to allow you to use Spark data frames directly in RSpark rather than using XDFDs. So that'll give you some more flexibility to use or share APIs in the future. And we're adding a lot of new model transformers in the MRS API. All right, that's all. There's some resources here. I do this course on Spark and R frequently, so you can find the course materials there. And I'm working on some notes as well, so you can find those there. And that's the SparkR website. All right, thank you.
Any questions for Ali? Questions? Thank you.
There's a mic coming for you, so 1 second.
Thank you for the presentation. You seem to have used only reverse scale functions, yeah? How do you use, say, any other library from R that you can actually just pass to Spark using ROX Spark context?
Yeah, so the question was, how would you use not a RevoScalar function, but a regular base R function or any package function? So we have, in order to work with XDF datasets, so the datasets that live in HDFS or in a distributed file system, you need to use R algorithms for that because they're designed to work with them. But what you could do is where I had, let me see if I can find that quickly. Yeah, right around here. So here I said, execute this function, the estimate model function, on, well, in this case, estimate this model function on these arguments, right? This function could take a XDF data set, but it could apply regular R functions on it. So then each function will be applied to a chunk of data, and then you had to summarize it yourself. So that's your way of creating your own PIMA algorithm. So it won't allow you to, say, have a global function that will work across the entire data set, but you could do it on a chunk-by-chunk basis and then aggregate it yourself. So RCZEC will allow you to apply your own user-defined functions. For transformations, if you want to do like subsets or mutations, there's another function for that called RDataStep, which is over here. So in here, you can provide your own transformations inside of a XDF data object. There could be a regular R package for that.
Thanks.
Any more questions? All right. Thank you.
Okay, thanks very much. Thank you.